In this tutorial, we're going to have a look at how to create particle systems on the PlayStation Vita. And particle systems are the way that many game developers model things like fire and smoke, explosions, water, and so on. The basic idea is that we're going to start by programming the behavior of one particle, and then we're going to create a whole bunch of them that behave independently but act as part of a larger system. Because we need a lot of particles on the screen, we have to hold them in something, so we have to get into data structures. Specifically, we're going to be looking at a list, so if you haven't seen the list tutorial, you may want to go back and check that out first. Alright, so looking at the PlayStation Mobile Studio again, you can see that we need to create a project, and I'm going to keep this one separate, but I'm going to integrate some of these concepts into that dual-stick shooter game that we created in the last tutorial. So we'll begin by creating a PlayStation Mobile application, and we'll call this one Tutorial 3. And again, make sure that you have this checkbox selected here, Create Directory for Solution. Alright, so I'll come over here and do a similar thing that we did last time. I'll start by creating a new folder, and I'll call that Assets. And then I'll shrink this down, and because I have that Assets folder, I'm going to start to move content into it. So you can see here's Assets. And over here in the Assets directory, you should have access to all of these things. I have Fire. I'm going to be using the Fire texture, as well as Particle and Particle Large. You may want to play around with that as well. And then also this smoke texture. So let's copy those, and we'll paste them here into the Assets directory. We'll also come over here and into the Shaders directory. We'll keep that same fragment shader there, and here's the vertex shader. Grab those guys and paste them in. And then finally we'll come over here into this main directory, and where's our sprite? Here it is. So we'll grab that guy and paste it here. Jump back over to the IDE, and I'll import all of those assets. So let's add these files, specifically these PNG files. Come over here, add the shaders as well. Here they are, sprite. And then we'll also add to the solution here, or I'm sorry, to the project, we'll add a file, and it's going to be our sprite class. Now again, if you remember, our sprite class was the key to making realistic looking kind of stuff, at least with regard to particle systems and blending. And so if you drop down here, you look the beginning of new stuff and the end of new stuff. There's a couple of different options that are currently commented out. I'm going to start by showing you the original that we had. Oop, not that one, but this one. And I'll comment out the additive blending because I want you to understand the effect that this is going to have on the way things appear visually. So let's go ahead and save that. Also, I'll jump up here just to make sure and change it from the fire test that I had before to tut3. Okay, save those changes, and let's shrink that down and jump back over here to app main. Alright, now what I'd like to be able to do is to create one particle, but I currently don't have a particle class. Now a particle is just going to be something that has a sprite in it, and it has a position and a velocity and a couple of other things, so it makes sense for us to go ahead and create a new class. So let's right click on tut3. We'll say add a new file, and again we'll create an empty class here called particle. And we're going to be using this later on, so make sure that you comment whatever you can. I'll come back over here to appmain.cs and grab these using statements, and in this case paste them right after this. Okay, and then we'll start to look at what it takes to make a particle. Now, as I stated before, a particle has a position and a velocity and things like that, a lot of physics related to it, but it also has a sprite. So let's begin there. We can say sprite, and you can call it sprite, and these will all be private for now, that's fine. We'll create a vector 3 for position, just like we did last time, and then we'll also create a vector 3 for the velocity. Now you could have put these on one line, but I like to keep them separate. Also, we're going to have this bool is alive, just like we had last time, to say whether or not this particle is alive, and we'll figure out how to kill these particles later, but for now we'll just leave it that way. We also have a constructor, and I'm going to set up the constructor a slightly different way than we did before. First thing I'll do is create this graphics context that we'll call context. We'll also go ahead and just pass in the texture 2D, and we'll call it text. Now the reason that we do this is because you have one particle that has one texture, but essentially what we want to do is share that texture for all of the particles that are on the screen. So this is going to be one way that allows us to do that. I'll also create a vector 3 for the position, and a vector 3 for the initial velocity. We'll just call that vel. Alright, I'll drop down here, bring the sprite to life. Sprite gets a new sprite, passing it the context and the texture. Next thing I'll do is I'll say this.pause gets pause, and again that's just a reminder to say I'm assigning the class variable pause, gets the value of pause, which is this guy coming in as a parameter. Do the same thing for this.vel gets vel, and then also I'll go ahead and set the isAlive to be true. Alright, because particles are alive, we have an update, public void update. I'm not going to have to pass it the gamepad data like we did last time because these are not going to be affected by the gamepad. We could have something where people draw smoke and fire on the screen, but we won't be doing that here. Okay, so I'll say that pause plus equals vel. And this is a huge concept. Essentially what we're doing is saying that a velocity, at least in this case, is going to be constant. We can apply gravity later, but for now we'll assume that velocity is constant. So what we're going to do is to update the position based on how fast this thing is going. So because this is being called 20, 30, 50, 60 times a second, you can see that we're going to increment the position in very small amounts, and this is how animation is done. In this case, it's going to be based off of the velocity. Also, what I'll do is to make sure that the sprite's position is going to be updated. Sprite.position gets pause, and that's going to copy over the x and the y. And we'll leave it that way for now. We may come back in just a second. And then the last thing here is to include public void render. And again, we'll just draw the sprite. Sprite dot render. Okay, now this is good for now. Again, this is just going to be an individual, and we're going to change this around just a little bit to get some really cool effects. But let's go ahead and shut this for now. And we'll come back over here to app main. Now, it's probably a good idea just to play around with one particle and see how that's going to behave. So what I'll do is come over here and create one. So because we have that, I'll say public static particle, and you can see that it recognizes it, and I'll just call it probably just particle for now, because we're going to get rid of this code. We're actually going to have a list of particles. Also, it's always a good idea to have the screen width and screen height. Let's just go ahead and stub that in, static int screen width and screen height. I don't think we'll be using that, but it's always just a good idea to have it. Okay, we'll drop down here to initialize, and just after we bring the graphics to life, I can say that screen width gets graphics.screen.width, and do the same thing for screen height. And this might be a good idea in case you want the particles to wrap around the screen. It's always a good idea just to have, like I said before. Okay, so let's bring a particle to life, and to be able to do that, I need to load a texture. You can see that I have a couple different options here. There's particle PNG, there's particle large.png, and maybe we'll start around with this so you can see how this is going to behave, and then we'll move on to fire and smoke in just a second. So right here what I'll do is I'll go ahead and load the texture, texture 2D, and we'll call it, I guess, party text or something like that. Gets a new texture 2D. Pass it the name, which is going to be application assets / and let's start with particle, particle.png, and pass it false as well. Okay, so I should have enough information to create a particle, but I still need to know where I'm going to put it on the screen. So let's create a couple of temporary variables here. Vector3, let's call it temp pause, and where are we going to put this? Maybe 200 over, 200 down, something like that, with 0 deep. Okay, we also have vector3 temp velocity. And remember, this velocity is going to drive the position. So we'll say that initially, let's make it move over very slow on the screen here, 0.5 pixels over each time. Let's not make it move on the Y position at all. So 0.0f, and then of course C doesn't make sense in a 2D game, at least at this point. Okay, so let's bring that particle to life. We could say that particle gets a new particle, passing it the context, which is going to be graphics. We would pass it the texture, which is party text. After that, we would pass it the position, which is going to be temp pause. And then finally, temp velocity is going to be the last parameter. Okay, so the particle is alive. We also need to be able to render this particle. So here inside of update, what I'll do is say particle.update. And then down here to actually render it, I'll say particle.render. Okay? Now at this point, we're really not going to have a whole lot. In fact, it's not going to be impressive at all. So I'll go ahead and run it. And you can see that we have a black background like we saw before, and we have this kind of gradient particle that's moving slowly across the screen. Now, where this is really going to get interesting is when we have a whole bunch of these things on the screen. This looks kind of lame right now, but it's about to change here in just a second. Just to show you what some of these other textures look like, let me kill this. Come over here and particle large, we could go ahead and just show you that real quick. Not a whole lot to that. It's basically the same version except larger. Okay, and of course you could scale that. The fire texture here is going to have a slightly different look. So if I run it now with fire, you can see it's this little ball of fire. Again, not very impressive. And then here with smoke, it's basically the same texture as fire. It's just that it has a gradient as opposed to color. So you can see it looks the same. It has the same shape. Okay, so now what are we going to do? Let's come over here and inside of app main create a whole bunch of these things, because this is where it really gets interesting. So this is where we start to dive into collections, and you probably have already seen these before, but here system.collections.generic is where a list is defined. So let's start by creating a public static list, and notice that list takes this template again. So we want a list of particles. This syntax takes a while to get used to, but understand that this is the data type here, right? This is a list of particles. That's the thing that we're creating, and let's call it party list. Okay? Now realize that because this is a list, it's an object, and it's therefore null, it's dead. So let's drop down here, and just after creating the screen width and screen height, or filling those variables, let's say that the party list, here it is, gets a new list of particles, and we're calling the constructor, and right now there are no particles inside of this particle list. Now this is where it gets interesting, because I said that we could reuse that texture. Notice that I'm only calling this once, but I'm going to pass it multiple times. Okay, so I'll drop down here, and I'll say that all of the positions are going to be the same, and for now let's just say for int I get 0, so long as I is less than 100, I++, and we'll create the particle like we did last time. In fact, I'll tab this over so it's a little bit easier to read. Notice that we have the temp vel on the inside of the loop and the temp position outside, and this is going to change here in just a minute on how we create this temporary velocity, but the position of all of these particles is going to be the same point. It's all going to emit from 200 to 200. In fact, what would be better here is if we change this to screen width divided by 2, in other words the middle of the screen, and screen height divided by 2, and therefore it's going to be a little bit more centered in the screen. Okay, now because we have a list, I have a whole bunch of particles. In fact, I have 100 particles I'm creating here. I haven't done anything. I haven't added these to the list, and this is a really easy step to forget. So let's say that party list right here .add particle. And so what this loop is essentially doing is it's creating a particle, it's adding it. It's creating a particle, it's adding it. It does this 100 times. So at this point in the code here at line 49, we would actually have 100 live particles inside this particle system. Now one of the nicest things about C# is that it has this for each concept. So instead of saying particle.update, that's an individual particle. Watch what I can do. I could say for each particle P inside the party list, then tell P to update. So I'll ditch that article thing and tab it over. And you can see what's going to happen here is we're looping through this entire list and telling everything. For all the particles that are there, tell them to update. We'll do the same thing down here. Use that for each loop again. For each particle P in the party list, then drop this down, say particle.render, and I'll ditch these other empty spaces here. Okay, so now we've told all of the particles to render, make sure that says P, with this one simple loop. And that's pretty convenient, and we're going to do the same thing later on when we get into enemies and polymorphism, so get used to this concept of a for each loop. Could you do it with a for loop? Yes, you could, but there's going to be some problems that arise a little bit later on. It's just an easier loop to work with in this case. All right, good. So if I were to run this now, you can see that I get kind of this blob of stuff and it moves across the screen. And you may be asking, well, didn't we just create 100 particles? Well, we did, but we started them off all in the same point on the screen, and then they also are going in the exact same direction. So if you look, the real problem is not with this line of code here in line 42 where we create the position. It's with the velocity here. They all start off with the same velocity. So what we need to do is not hard code this to be 0.5 and 0.0. Instead, let's come up here and create a random number generator. So let's say public static random, and I'll call this thing a generator. We need to bring that generator to life. I'll do that right after the graphics here. Let's say generator gets a new random. Okay, and there's a couple of different things that we can pass here. And you have to be careful because whenever I ask for a random number from the random number generator, I get an int or I get a double. There is no generate random float from what I know. So we'll say generator.next double. And notice that this thing is going to return us a value between 0 and 1. And that's going to be a little bit problematic later on, but for now let's just see what happens. And we'll do the same thing here. We'll say a float version of whatever generator.next double returns. Okay? So at this point, we should have random x and random y values for the velocity. If I were to run it now, you can see that we get this kind of hiccup at the beginning. That's just my system. Hopefully you're not getting the same thing. And because we're using the smoke texture, you can see that it goes out, but it goes out actually in a square, which is kind of weird. And notice that everything goes down and to the right. And you may be asking, why are we getting these behaviors? Well, let's solve these things one by one. Okay, so the first thing is this random number generator right here does a good job, but it's always returning us something between 0 and 1. In other words, it's always returning us something positive. What I really would like to have happen is have it return us something between negative 0.5 and positive 0.5. So because this value right here is returning us something 0 to 1, watch what I can do. I can just say minus 0.5. Okay? So right there you can see that if it returns us a 0, it's actually going to, this whole expression is going to return us a negative 0.5. If it returns us a 1 over here, we subtract 0.5 and it's going to give us the maximum range of 0.5. We'll do the same thing over here. We'll subtract off 0.5. And now when we run it, we're going to get it going in all directions. It starts generally in the middle of the screen. And now you can see it goes out in all directions. Now the next question is, why is it going out in a square? Well, that's the way that we actually told it to go out. Realize that x and y are independent, and so therefore our minimum negative x is negative 0.5, and our positive x is going to be positive 0.5, and the same thing is true for our y position. So that's why we're getting this square. Instead of creating this independent x and y, what we really need to be able to do is to create an independent angle. So watch what we're going to do. I'm going to comment this out for now because this is really not the way that I want to do it. Instead, I'll say float angle gets generator dot get double. Okay, and again, this returns us a value between 0 and 1, and I'm going to scale that up by 2 radians, 6.28, and that's close enough for what it is that we're going to do here. And then, of course, I'll have to typecast this to be a float. All right, now when I do this, I have a value that's going to go around the unit circle, and what I can then do is to break this into a couple different parts. So I'll copy this line of code here. I'll come down here, and instead of saying this generator stuff right here, I could say, I'll use the fmath.cosine of the angle. And I'll do the same thing here for the y component, fmath.sine of the angle. And when I do this, it's going to give me a much different effect. So I'll go ahead and run it, and you can see it generally starts on the screen, but now we get this circular shape. Well, this is kind of cool. I mean, you've seen a lot of space movies where things, when they explode, they go out in something that looks like this. But it still has some problems, right? Because it doesn't fill the screen. It doesn't look like a real explosion. So a couple of different things that we could do is that we can give them random speeds as well. So watch what I can do. I could say float speed gets a float version of generator.nextDouble. And let's say that the speed can be up to 3 units, whatever those units are. I don't even really know. But then I can multiply the first value here that I'm passing to the vector. It's x velocity times speed. And I'll do the same thing here. Multiply the y velocity times speed. And when I do something like this, I get something that's a little bit more random. Okay, and again, this is only 100. Most particle systems could have 500, 1,000, 10,000 even sometimes. Okay? All right, good. So now, as promised, we can go back over here to particle, and we can change a couple of things. Now, if I were to run this again, notice that everything kind of goes out in this unit circle. It looks good, but things stay on the screen forever. So we really can't have that. Particles are supposed to fade over time. They're supposed to die. So I'm going to go ahead and kill this and code up that concept. Now, the first thing that I like to do is to create an age variable, which is just an int. And then what I'll do is I'll set the age to be 255. And you've probably seen this number a lot of times. It's 2 to the 8th minus 1. Computer scientists like the number 255. And I'm going to use this in a couple of different ways. If the age ever gets down to 0, then I know that this particle is no longer alive. So let's go ahead and code in that concept. I could say something like, if age is less than or equal to 0, then I know that this particle has been around long enough. So I'll say isAlive gets false. And then I can check for that in app main if I were to make this isAlive public. Okay, so we could clean up our list. We could have dead particles that get removed from that list, and so on. Okay, other couple different things. You can see that age has not been decremented. So every frame, what we'll do is to decrement the age. Now, if I were to run this again, you're not going to see anything because we're not doing anything with that information yet, but at least the particles have the concept of age, and that isAlive value is getting flipped when it should be. Okay, so watch what we could do with that age. Another really nice thing is these particles should kind of go away. They should fade away the older that they are. So to encode that concept, what I'm going to do is to create a new color based off of that age. And I say a new color, but specifically what I'm going to do is mess around with the alpha value. So new color gets a new vector 4. And for now, let's just do this. We'll say 1.0f, 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 in other words, the color white. And then right here, watch what I'm going to do. I'm going to say I want a float version of age, but I'm going to put it over the value 255.0f. Now, the effect of what's going on here is this last parameter is that age is getting decremented. So the first time that update is called for this particle, its transparency has the value of 1. Now, over time, what's happening is because age is getting decremented, that ratio right there of age over 255 is going from 1, and eventually it gets down to 0, meaning that it is no longer visible on the screen. The last thing that we need to do is to use this new color. So I'll drop down here and say sprite.setColor. And I'll pass it the new color that we just created. And when I run it at this point, you're going to see we get something that looks kind of cool, right? Things fade out. I can also do this. I can change that texture from smoke. I'll change it over here to fire. You can see it kind of goes out. But it still looks a little bit lame because things are being drawn over top of each other. In fact, I'll run that one more time, and if you look closely, you can see that these particles kind of overlap on top of each other. They don't look like a cohesive system. So this is why I rewrote this sprite class. If you drop down again, there's some new code. Yes, we do have a rotation. You could rotate your particles if you wanted to do something like that. Shrink this region down. Okay. And you can see there's some new code, but what I want you to start messing around with is this guy right here on 184. Notice the graphics.setBlend and we pass it a couple of different things. So I gave you some options, and let's play around with these. I'm going to comment out the original version that came with the sprite class, and I'm going to uncomment line 187 here. And this is a weird kind of effect, but I wanted you to see that there are a couple different options. You can see we get this very bizarre looking thing. It's not very useful, but it's still cool. I'll come back over here, I'll comment that back out, and this is the one that we're going to be using here. So we're going to pass this set blendFunc mode.add, and also source alpha as the second one. You can see we have this blendFunc factor, and then also the blendFunc factor of 1. And this is going to give a much different effect, but it's only going to be useful for when we're trying to do things like particle systems. So when I run it at this point, you can see we get this very glowing kind of effect. Okay, in fact, what I'll do is I'll take this up even higher over here in app main. Instead of just 100, it's going to be a little bit slow on my system because I'm recording, but if I take it up to 200, you can see we get these intense hot spots in the middle of this system. Right, so that's pretty cool. Again, you can rotate these things, you can decrease their size, you can increase their size. There's 1,000 different things that you can do with these particle systems. So one of the things that we're going to be doing here is to integrate the particle system that you see here back into the dual stick shooter for the Vita. And the reason is because we're going to implement a flamethrower. So that's it for now. Hopefully you understand a little bit more about what particle systems are and how you can use them in games.